Earthquakes could soon be predicted at least 2 hours in advance thanks to GPS. By analyzing GPS data, scientists found subtle shifts along fault zones up to 2 hours before major earthquakes. Earthquakes occur when stress builds up along a fault, causing a sudden slip. Scientists have debated whether this slip occurs instantly or gradually, with detectable warning signs. Now, they have discovered that small but accelerating slips between tectonic plates occur in the lead-up to earthquakes, which can serve as indicators if detected. Previous research in this area had only examined a few earthquakes and produced inconsistent warning signs. To prove their theory, the scientists collected GPS measurements every 5 minutes for 48 hours before 90 different earthquakes. They compared the movements recorded by the GPS with what was expected during an earthquake. They noticed that right before each earthquake, there was a big movement in the expected direction. The movements kept getting bigger as the earthquake approached. However, the current GPS sensors make too much noise, which only allows for detection based on large data sets rather than individual sites. Further progress in earthquake prediction requires GPS sensors that can detect movements as small as 0.1 millimeters.
Earth seems to have a rhythmic pattern, similar to a heartbeat that occurs approximately every 27 million years. This pattern is linked to volcanic eruptions, mass extinctions, and changes in sea level, according to a recent study. Contrary to the belief that geological events are random, the study provides statistical evidence suggesting that these events are correlated and not haphazard. Using radioisotopic dating techniques, researchers examined 89 major geological events spanning 260 million years. These events included extinctions in both marine and land environments, volcanic eruptions, and episodes of oxygen depletion in oceans. Scientists discovered these events clustered around 10 different time points throughout the 260 million years. They occurred in pulses, separated by approximately 27.5 million years. The most recent cluster of geological events was roughly 7 million years ago, indicating that the next cluster is expected in about 20 million years. While the exact cause is yet to be determined, the researchers speculate that these pulses could be influenced by plate tectonics or astronomical cycles. This challenges the traditional belief held by many geologists and supports the idea of a predominantly periodic, coordinated, and intermittently catastrophic geological record. The new research could help us predict upcoming cycles of catastrophic disasters that could hit the planet in the distant future.
A massive earthquake shook Seattle 1100 years ago, and it could happen again. Around 1100 years ago, 2 faults near Seattle ruptured simultaneously, an event that had far greater seismic impact than previously believed. If a similar event were to occur again, the resulting earthquake could be more than 30 times larger than what researchers initially expected based on their modeling. Earthquakes occur when the friction holding tectonic plates together is overcome by stress, releasing energy in waves that cause shaking. The Seattle Fault, situated along the northern border of Seattle and extending to the Olympic Peninsula, is one of several fault lines in the United States. The study examined a seismic event that occurred over a millennium ago, causing landslides and a local tsunami, submerging and burying numerous trees across a 193-square-mile area. The study suggests that the earthquake could have been a single event with a magnitude of 7.8 or 2 separate earthquakes with magnitudes of 7.5 and 7.3. The region is known to be seismically active and structurally complex, making it particularly vulnerable to the serious hazard of earthquakes. Scientists are urging authorities to take appropriate measures to mitigate the potential implications of a multi-fault earthquake in the Seattle metropolitan area.